Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, we are going to discuss about the topic Arduino, its architecture, what are the various pins, various families existing in the Arduino. This we are going to discuss in detail. So, in this session, we are going to discuss the features of Arduino, what will be there on the Arduino board, the various Arduino boards which are existing in the Arduino family, a glimpse on sensors, shields, and Arduino IDE. So Arduino is an open source platform that is used for building the projects for mainly a embedded system application. For any autonomous kind of thing also possible. So Arduino consists of both a physical programmable circuit board and the software or IDE, that is integrated development environment, that runs on computer used to write and upload the computer code to the physical board. Unlike most programmable circuit boards, the Arduino does not need a separate piece of hardware which will call as a programmer that is needed for load the new code onto the target board. So the Arduino IDE uses a simplified version of a C++ language, make it easier to learn to program for a particular application. So Arduino provides a standard form functions of the microcontroller into a more accessible package. There are many varieties of Arduino boards that can be used for different purposes. Out of all the existing Arduino boards, the Arduino Uno is one of the most popular boards in the Arduino family and a great choice for beginners, and most Arduinos have the majority of the components in common. The figure shows the Arduino Uno board. In this Arduino Uno board, we can see a number of components are existing. First, we will see the power boards, which is you can connect the Arduino board with USB, or we can connect through barrel jack. So every Arduino boards need a power source. So it powers from a USB cable or a barrel jack. So in the figure, the USB connection is labeled as 1 and the barrel jack is labeled as 2. So the USB connection is also used to load the code onto the Arduino board. Note, do not need a power supply greater than 20 volts. So the recommended voltages for most of the Arduino family models lies between 6 volts to 12 volts of DC supply. Next we have the ground and the DC power supply sources for power. Here we can see the pin 3, that is naming which we are given as 3, which we have 2 ground pins. So this is GND, it is for a shortcut of ground. There are several ground pins on the Arduino, one of which can be used to ground your circuit. Whereas the DC power supplies, which is 5 volts, and this is for 3.3 volts. So the numbering or label which is given as 4, it is for a 5 volt supply, and the numbering which is labeled as 5, this is for 3.3 volts power supply. Most of these simple components used in the Arduino run happily of 3.3 volts or 5 volts supply. Next, you can see the analog pins. So the analog in labeled, that is from A0 to A5, total 6 channel are existing to take the analog input pins. These pin can read the signals from a analog sensor like a temperature sensor and convert into a digital value that can be read and processed by the processor in the Arduino board. Next, we'll come to the digital I/O pins. On the top here, we can see the digital pins, that is pin number 0 to pin number 13. So total of 14 DIOs are existing on Arduino Uno board. These can be used for both a digital input and a digital output. Next, PWM, that is pulse width modulation. Here the pin 3 and the DIO pin 5, the pin 6, pin 9, 10, 11. These are used for PWM cases. So the DIOs with the pin number is given with a tilde that indicates these pins we can use for a PWM signals. So in this board, pin number 3, pin number 5, pin number 6, pin number 9, 10 and 11. These are used as DIOs as well as for PWM. So these pins generally act as a DIOs, but can be also used something called pulse width modulation. These pins as being able to simulate the analog output like fading of LED in and out. So the PWM signals, it can be used for varying the intensity of the LEDs mainly. Next we have A reference. So this A reference stands for analog reference. Most of the time this pin left alone. It is sometimes used to set the external reference voltages, that is lies between 0 to 5 volts as the upper limit for the analog input pins. Next we have a reset pin. So the Arduino has a reset button which is labeled as 10. Pushing it will temporarily connect the reset pin to the ground and restart any code that is loaded on the Arduino. This can be very useful if your code does not repeat but you want to test it for multiple times. Next we have the power indicators. The tiny LED next onto the word on, beneath to this here you can see on, here you can see a tiny LEDs are present. So this LED should be light up whenever the Arduino board is powered. That is nothing but Arduino plugging into the power source. If the light does not turn on, there is a chance something went wrong. So we have to recheck the circuit. Next we have transmit, receive LEDs. These pins indicates for serial communication for transmission and receiving. There are two places on Arduino Uno where TX RX appear. One by a digital pin 0 and 1. The second one is next to TX and RX indicator LED, that is in the 12th location. These LEDs will give the visual indication whenever the Arduino is receiving or transmitting the data. Like whenever the program is loaded onto the board also, it will be gives the representation for a visualization of the existing of the data transfer between Arduino and external. So the main IC, so the black thing which all the metal legs is an IC or integrated circuit which is labeled as 13. The main IC on the Arduino is slightly different from board type to board type, but it is usually from the Atmega line of ICs from the Atmel company. So need to know the IC types along with the board type before loading up a new program from the Arduino software. Next, the voltage regulator. So the voltage regulator with the label 14 controls the amount of voltage that is let into the Arduino board. Think of it's a kind of a gatekeeper. It will turn away an extra voltage that may harm the circuit. Of course, it has its limits. So do not hook up the Arduino to anything greater than the 20 volts. If you give more than 20 volts, damage will be occurred for the Arduino board. So Arduino makes several different boards with different capabilities under Arduino family. In addition, a part of being open source hardware means that the others can modify and produce the derivatives of Arduino boards that provide even more factors and functionalities. So under Arduino family, the first one which we are going to discuss is Arduino Uno R3. This Arduino Uno has 14 digital IO pins, that is pin number 0 to pin number 13, out of which 6 can be used as pulse width modulation, and we have 6 analog inputs, a USB connection, a power jack, a reset button, and more exist on the Arduino Uno R3 board. It contains everything needed to support the microcontroller can connect it to a computer with a USB cable or power to AC to DC adapter or battery to get started. Under Arduino family, the next type of Arduino board is LilyPad Arduino. This LilyPad is a wearable e-textile technology developed. Each lily pad was creatively designed with a large connecting pads and flat back to allow them to sew into the cloth with conductive thread. The lily pad has its own family of input, output, power and sensor boards that are also built specifically for e-textiles. These LilyPad Arduino boards are even washable. The next Arduino family will comes as Redboard. So the Redboard can be programmed over a USB mini B cable using the Arduino Uno IDE. It is completely flat on the back, making it easier to embed it in the projects. Just plug the board, set Arduino Uno from the board menu and you are ready to upload the code. It can powered over USB or through the barrel jack. The onboard power regulator can handle any voltage lies between 7 volts to 15 volts at DC source. The next Arduino family will comes with Arduino Mega, that is R3. The Arduino Mega is like the Uno's big brother. It has lot of DIOs, around 54. Out of these 54 pins, 14 pins are used as pulse width modulation outputs, 16 analog inputs, a USB connection, power jack, and a reset button. The large number of pins make this board very handy for projects that require a bunch of digital inputs or outputs. Next come with the Arduino Leonardo. The Leonardo is Arduino's first development board to use one microcontroller with a built-in USB. It can be cheaper and simpler. Also, because the board is handling USB directly, code libraries are available which allow the board to emulate a computer keyboard, mouse, and much more, which are connected to the USB. Next, we'll see sensors. So the Arduino can control and interact with a variety of sensors that can measure light, temperature, pressure, proximity, acceleration, carbon monoxide, radioactivity, humidity, barometer, pressure, and the various sensors we can see in the figure. So these will support for connecting to the Arduino board for acquiring the physical parameters. Few of the sensors may give the output, that is sense data, as a digital or analog form. Next, shields. So additionally, there are something called as shields. Basically, they are pre-built circuit boards that can fit on the top of the Arduino and provide additional capabilities like controlling motors, connecting to the internet, providing cellular or other wireless communication, controlling an LCD screen, and much more. So the figure shows the various shields which are able to mount on the Arduino boards. Next, for programming the Arduino, we are going to use Arduino IDE. The IDE makes the traditional projects even easier and simpler. The USB cable is used to load the program or sketch onto the specific Arduino board. The IDE application is suitable for the various platforms like Windows, Mac OS, and Linux. It supports C and C++. Connect the Genio and Arduino board with the IDE to upload the sketch written in the Arduino IDE software. Sketch is nothing but the program which we are writing in the Arduino that we call as sketch program. So here this is the how the editor will looks, where we are going to write a sequence of the steps to be executed on the Arduino board. So before starting doing anything with the Arduino, first download and install Arduino IDE, that is Integrated Development Environment. The Arduino IDE has the Arduino programmer, which is used for dump the code onto the Arduino board. The Arduino programmer is based on processing IDE and uses a variation of the C and C++ programming languages. Next, how we can connect the Arduino with the laptop or PC using the USB cable. Although the Arduino plugs into computer, it is not a true USB device. The board has a several chip that allows it show up as a virtual serial port when it is plugged into a USB port. This is why it is important to plug the board in. It is also good to know that every single Arduino has a unique virtual serial port address. This means that every time when we plug a different Arduino board to the laptop or computer desktop, we will need to reconfigure the serial port that is used in IDE software. So before starting anything in the Arduino programmer, we had to set the board type as we have seen in the previous slides, the various Arduino family which are existing. So we had to select the appropriate board which we are going to use for developing of an application. And we had to select the serial port also. To set the board, go to the tools. Under that we can see boards. It is going to display a list of the Arduino boards. So which are the Arduino board which we are using for programming, that we are going to select here. Select the version of the board that you are using. Example, if you are selecting Arduino Uno, if you are plugged to the laptop, then we have to select under the boards Arduino Uno. To select the serial port, go to tools. There we can go for serial port selection. So this is the IDE. Under this, you can see for setting under the tools, then select the board. It is going to display the various boards which are existing in the Arduino family, which are the board which you are going to connect, that we are going to select here. So let us consider if it is Arduino Uno, we are going to select that particular Arduino Uno board. If you are changing to Arduino Mega or Red board, you can select appropriate. The next one is for setting up the serial port. Again, tools option. Under this, you can see the serial port. Here it is going to display, depending upon our system, it is going to display the serial ports. We can select one of the serial port which are supporting the Arduino board. Next, how we can run the program which we call as sketch. So in Arduino IDE environment, if you go to file under examples, we can see the various applications are predefined. A piece of code will be exist that we can make use for developing a particular kind of application if the element is existing in the examples. So let us consider under blinks. Again, you can say analog read serial, bare minimum, blink, digital read signal, fail. So whichever you want, that you can select. So to get the LED tied to the digital pin 13 to blink on and off, let's load the blink example which we are having here. So the blink example can be found here under the files, then examples, under basics, you can see the blink. The blink example basically sets the pin, that is digital 13th pin, as output and then blinks the test LED. The Arduino programs are called as sketches. The Arduino programmer comes with a ton of example sketches which are pre-loaded in the IDE. Next, serial monitor. If you want to display the data which are acquiring and we want to put that one as a serial data to be printed, so we have a serial monitor. The serial monitor allows to connect the computer serial E with the Arduino. So this is important because it takes the data from the Arduino, which is receiving from the sensor and other devices, and display it in the real time on a computer. So here we are going to write the steps for displaying the serial data. We have to select the baud rate and which data you are going to print, that you can send as a argument. Now, The various elements which we can connect for the Arduino, they are of digital in, digital out, analog in. So we will see one in detail. So the digital in, the Arduino has two different types of the input ports. Those are being either analog or digital. So the digital inputs have only two possible states, which are on state or off state. So these two on and off states can also be referred as high or low, 1 or 0. In terms of voltages, logic 1 as 5 volts and logic 0 as 0 volts. This input is commonly used to sense the presence of the voltage when a switch is opened or closed. So this is a sensor where you can see we have the three pins. Here, these pins, the significance is displayed on the board. So depending upon the pin, we have to connect to the appropriate pin on the Arduino. Next, analog in. So as the Arduino boasts a number of analog inputs, the analog input takes an analog signal and perform it for a 10-bit analog to digital conversion to turn it a number between 0 to 1023, that is up to 4.9 millivolt steps. This type of input is good for reading resistive sensors. These are basically sensors which provide resistance to the circuit. They are also good for reading varying voltage signals between 0 to 5 volts. This is useful when interfacing with various types of analog circuitry. Next, a digital out. So a digital out pin can be set to be either logic 1 or logic 0, that we can consider as high or low. High will be with the 5 volts and the 0 will be with low volts. This allows to turn the things on and off. Aside from turning things on and off for making LEDs blink, this form the output is convenient for a number of applications. By turning the pin on and off rapidly, you are creating the binary states, that is changing the state from 0 to 1 or and 1 to 0 state, which is recognized by countless the other electronic devices as a binary signals. Now if you observe this LED is said to be in off state, whereas the second LED, the LED is on, so the LED is said to be in on state. Next we will see the analog output. So the Arduino has the pulse width modulation, which is the way an Arduino is able to create an analog like output. The pulse width modulation works by rapidly turning the PWM pin high and low to simulate an analog signal. If LED blinks on and off rapidly enough, it would be seen to average the brightness and only appear to be receiving half of the power. So PWM is used in applications like making sound, controlling the brightness of light and controlling the speed of the motors. If you observe, this LED is in off state, whereas the three LEDs are in on state. Whereas the brightness, the illumination of this LED compared with the other LEDs, there is a difference. So this we can achieve by applying the PWM signals for the LEDs so that the intensity of the light we can vary. So for preparing these slides, I have referred the websites like learn.sparkfun.com and instructables.com/intro to Arduino. So all the slides are prepared as well as figures also collected from these resources. Thank you. So in this session, we have discussed what is an Arduino board, what is the features of Arduino boards, applications, and various members existing as Arduino family. Next, the various pins which are existing in a Arduino Uno board, like how many DAOs it is having, unlock signals, PWM signals, receiver transmitter, reset, power charts. So this we are discussed in detail. Next, we have come across a few of the input output devices like a digital in, digital out, unlock in. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.